Good morning, dear students. Welcome to the online teaching for the session 2020-21. Myself, Mrs. Sati Joseph, your physics teacher. We will continue with the revision of chapter 1, that is motion. Today's first topic is equations of uniform accelerated motion. We have seen that there are three equations for the motion of those bodies which travels with a uniform acceleration, and these equations give relation between initial velocity, final velocity, time taken, acceleration and distance travelled by the body. These are the equations. First one is V is equal to U plus AT. Second is S is equal to ut plus half at square, and the third equation is v square is equal to u square plus 2as, where u is the initial velocity of the body, v final velocity of the body, a acceleration, s distance travelled by the body, and t is the time taken. And we can derive these three equations mathematically as well as graphically, as I have explained earlier. We can represent the data related to the motion of a body using a graph. There are two types of graphs. First one is a distance time graph, which means we will take the time along the x-axis and distance along the y-axis. The distance time graph of a body moving at a uniform speed is always a straight line, whereas that of a non-uniform motion is a curved line, and the slope of the distance time graph indicates speed. And second type of graph is speed or velocity time graph. That means we will take the time along the x-axis and speed or velocity along the y-axis. A speed time graph for a body moving with a constant speed is a straight line parallel to the time axis, and that of non-uniform motion will be a curved line. The slope of a distance time graph of a moving body gives its acceleration. We can also calculate the distance travelled by the body using a speed or velocity time graph. How? The area enclosed by the speed time curve and the time axis gives the distance travelled by the body. Suppose the speed time graph of a body is a straight line sloping upward, then it shows uniform acceleration. And on the other hand, if the graph is a straight line sloping downward, that indicates uniform retardation. And if the speed of the body changes in an irregular manner, then the speed time graph of the body is a curved line. Now let us see what is uniform circular motion. What is circular motion? If a body moves in a circle, it is called a circular motion. When a body moves in a circular path with uniform speed, then its motion is called a uniform circular motion. And we have seen that a force is required to make a body move in a circular path, and that force is called a centripetal force. So what is the definition of centripetal force? The force which is needed to make an object to travel in a circular path is called centripetal force. Now, how to calculate the speed of a body in uniform circular motion? If a body moves in a circular path, it covers a distance which is equal to the circumference of the circle. So, we can calculate the speed of the body in a uniform circular motion by using the formula V is equal to 2 pi r upon t, where pi is equal to 22 upon 7, V is equal to speed, r is equal to radius of the circle, and t is the time taken for one round of circular path. Here becomes the end of this module. You can see these videos at any time in between April 30 to June 10, and you will get the attendance also when you open these videos. Thank you. Bye bye and take care.